My name is Alex Frayer. I'm a first-year student of environmental science in the Rubenstein School.
Hi, my name is Alex Smith. I'm a second-year student in the Rubenstein School, and I'm studying environmental science.
Before we can explain the work we did on the green roof this semester, you need to know a little bit about green roofs in general. A green roof is defined as a roof of a building that is partially or completely covered by vegetation. Green roofs can include a variety of different vegetation and soil types.
The most important overarching factors of green roofs are their beneficial impact on stormwater management, addition of annual vegetation growth on impermeable surfaces, reduction of harmful solar radiation, and improvement on water quality. Specifically, the Aiken Green Roof is investigating the water retention of the seed and vegetation in various soil treatments. The green roof functions as a water catchment area by collecting 2 downpouring rains into 8 watersheds. With living plants and healthy soil, the water holds a high retention rate within each area.
The Aiken Center green roof was installed in 2013, and it is unique because it's a fully functioning research green roof. It consists of 8 individual watersheds, and there are 2 repetitions of each treatment. The treatments include control groups, standard soil and standard plants, alternative plants and standard soils, and standard plants with biochar added to the soil.
Water samples were collected from each of the watersheds on the roof and recorded to assess the quality of the runoff and its relationship to the different types of experimental treatments. During the spring, summer, and fall of 2014, numerous water samples were systematically collected and stored for testing.
When collecting water samples to be processed in the laboratory, the samples were organized by month and time. By writing the start time and date of collection period on each experimental bottle, the samples correlated to specific storms and climatic periods over the past year of collected data.
Once samples were organized, they were sent to the agricultural testing lab run by Joel Tilley for analysis. In this lab, latchet and ICP tests were performed to determine the amount of each element in each water sample. These results were used to calculate flux.
By determining the concentrations of different chemicals in the runoff from the roof, we can calculate flux. Flux is defined as the rate of flow per unit area. These figures give us an idea of how well the different watersheds can filter out certain contaminants, such as phosphorus and heavy metals, from the runoff.
When viewing the volumetric peak flow data, there is clearly a major difference in water retention rates between the watersheds. Specifically, the control watershed reaches a far greater water volume of runoff and peaks at a much earlier rate. For watershed 4, 7, and 8, the peak flows were fairly uniform until a larger storm was recorded. Particularly, watershed 4 and 7 were more effective at retaining stormwater runoff than watershed 8 with the biochar additive and standard plant type, as we can see, with a much higher volumetric peak flow.
The 2014 cumulative discharge graph shows the total cumulative discharge between the watersheds of 1, 4, 7, and 8. Watershed 1, which is a control, has the most cumulative discharge, while watershed 7, which is the standard plants and standard soil treatment, has the least cumulative discharge of all 4.
During spring, it is essential to fertilize the soil on the green roof so that the plants have the proper nutrients to grow. We will be using an organic fertilizer for our green roof this year called Plant Tone. By following the measurements recommended by the manufacturer, we calculated the exact mass of fertilizer needed per every 32 square feet of soil surface, which is the area of 4 plant beds on the green roof. Next, we practiced spreading the fertilizer evenly over a surface with this area to ensure equal treatment across the entire roof. We devised a system of marking each plot with 4 flats with colored flags before and after each was fertilized to ensure that we fertilized every flat and didn't do any more than once. Finally, we were ready to actually spread the fertilizer on the roof. We haven't had the time to fertilize the whole roof yet, but when the job is done, the roof will come to life and continue retaining and filtering our stormwater runoff throughout the rest of the year.
Overall, green roofs are very important because of their endless beneficial factors. These include rainwater runoff management, nutrient absorption, and reduction in urban heat islands. As well, Green roofs allow the perennial growth of native vegetation. In the end, it is obvious that green roofs are an important aspect of green architecture and design.